Hello everyone, welcome to a new video on Docker containers. So in this video, we are going to see what is the buzz around Docker containers and how does Docker containers work. What is the basic difference between containerization and virtualization, and how do we create custom Docker containers using Docker files, and finally how to create the Docker Compose YAML files. So that this video is going to be a bit long, so it will be divided into three parts. The first part we are going to see this, that is this part is going to be dealing with how to run Docker containers and the basic details about what are Docker containers. The second video will be dealing with how to create your own image files with the help of Docker files. And the third one will be where we are going to learn how to create Docker Compose files to deploy your uh, environments on Docker. So let us begin. So what is Docker? So Docker is a platform used to build, run, and manage lightweight virtual environments called containers. Okay. So now, if the word containers seem to be a new thing for you, then let's understand what are containers. So containers help developers package an application with all of its dependencies so it works consistently across different environments, whether it is your local laptop, a test server, or the cloud. So the major problem what developers face when they do any type of development work is that a common phrase that it's working on my PC, but when you try to run the program, it doesn't work. The main reason why this happens is because the version of some of the dependencies may be different when you installed it. So usually what happens is we do develop uh, on different machines, and when we develop in different machines, the libraries that we install may not be of the same version, right? So that's why whenever we try to develop something, um, it is possible that sometimes certain features works on one computer but it does not work on other computer. So for long there was this problem that we can ship the code, the source code of your program in, let's say, any GitHub or a Git repository, right? But unfortunately, we cannot ship our dev environment or the production environment in inside code, right? So we cannot write some code with which we can spin up a development environment or a production environment. So that is what the Docker container solves uh, in the world of development. So let's look at how it does that. So before we go ahead and see how it accomplishes it, let's first understand what is the difference, basic difference between virtual machines and containers. So as you know, virtual machines can also be used to create an isolated environment where you can install your different softwares and everything, right? Then why containers are much more popular than virtual machines? So virtual machines is like an an individual computer that is living inside the host machine. So it has everything related to the host machine. So, like for example, you can see in this diagram of how a virtual machine works. So on the host OS, there is an hypervisor, and every hypervisor has the guest OS, and on top of that, the app is installed, right? So every app has to go through the guest OS, then through the hypervisor to the host OS to reach the hardware, right? So the number of resources that you are allocating to virtual machines is much higher, right? So the idea was, why not we can share the OS? Why to unnecessarily waste on the underlying OS? Why can't we just share the OS and containerize only the application? So the concept of containers were introduced, where so the host OS is there, on which the Docker daemon will be running. Okay, so that is the Docker software, and on top of that Docker software, you will be running different containers. Now these containers will not need additional RAM or additional memory or CPU. It will be sharing the RAM and CPU that is allotted to the host OS. So in that way, it is much more efficient, and we can run many more containers than we could have run those many VMs. So that is the reason why containers or containerization has become such a huge term in development world. So let's look at some of the Docker terminology. So Docker terminology, very important. So we start with images. So images is the blueprint of our application, which forms the basis of containers. These contain all the configuration settings that define the isolated environment. So images in the broad sense is the blueprint which is used to run the container, right? So for example, in a very basic form, let's say we want to run Ubuntu container. So Ubuntu will be our image, right? Now the difference between an ISO and an image is ISO, we can download from, let's say, Ubuntu, go to Ubuntu website and download an ISO of Ubuntu. Now this ISO needs to be installed first, then only we can use it. But images are not like that. Images are already installed. It is ready to run as soon as you plug it in, right? So that is the difference between images and ISOs. So images are like blueprints. So it is something which is already ready to run. It cannot be written directly unless you change it using some scripts, but the images cannot is immutable, right? Now when you want to run these images, those images will be converted into containers. Okay, so the containers forms the basis, sorry, the images forms the basis for running the containers. So I can have one image and I can run 10 containers out of those images, right? So let's say I have a Ubuntu image, right? From this Ubuntu image I can run 10 containers, 10 different containers, all will be different in operation, right? So that is how, so images forms the starting point and containers are the things which run with the help of images. So now containers are actually writable, so we can write it, but the whatever contents that we write, it is volatile, so it will be destroyed after it is destroyed. Okay, so next we look at Docker daemon. So to run these containers we need a software, right? So the Docker daemon is the software which sits in the background, runs as a service, and listens for the calls that it receives from the Docker client, and based on whatever commands that we send it to the Docker daemon, it spins up or destroys a container. Now these, so basically, so Docker client is the place where you actually send the commands, and the Docker client sends these commands to Docker daemon to do the task. Okay, so this is the server, and this is the client. Now Docker Hub is where you can find publicly accessible images. Okay, so if you want to get images to run certain containers, you can either build your own image from a starting base image, or you can get a image from Docker Hub, right? So we will look into this a little bit more a little later. Okay, so let's look at the difference between what is a Docker image and a container. So Docker image, a read-only template containing everything needed to run an application, including code, runtime, system tools, libraries, and settings. So it is like a blueprint. It has everything that is needed. So like for example, if you are building a Python app, then it will have Python installed in it. It will also have all the libraries, like maybe you are using pandas, numpy, matplot, whatever. So all those will be installed, and it will also be configured in such a way that if you try to run this, it will not need anything else. So everything is configured in such a way that everything works out of the box. So that is what a Docker image is. Okay, the important point here is it's read only. Okay, now what are the characteristics? It is immutable. Once created, an image cannot be directly modified. Instead, you can create new images based on this image. So you can add on to the image that you start with, and you can add additional features, but you cannot change the original image. It is lightweight, so images are designed to be small and efficient. So it is optimized in such a way that it should work very fast. It is should be portable. Portable meaning that it should not create a problem that it works on one type of OS and it does not on the other OS. So it is portable, and it is layered. Now this word layered is very important, because layered means the whatever actions that you do while creating an image. Let's say for example, you start with Ubuntu and then you install let's say Python inside this image. Okay, so now this installation of Python is cached. So the second time when you run it, it will not run the layers which is already done. Okay, so if a particular layer is already built up, then it will not run that layer again, or it will not build that layer again unless the underlying layer has changed. Okay, so that is the one of the main reasons. So if you try to build the same image again and again, it will be the first time it will take more time. The consecutive times when you build it, it will be much more faster because of this layered architecture. So an example of an image is a Docker image for a web server, in which it may have an Nginx runtime environment and a Python, Node.js, or a PHP platform installed, and the code of the application. So this is an example of how a Docker image may be. Okay, now let's look at a container. Now the container is a running instance of an image. So if you take an image and if you run it, that converts it into a container. Okay, so if you want to see how the image looks like, you have to run it, and when you run an image, you get a container, right? So container is an isolated environment for an application to run. So if you take an image, let's say this Docker image that you have created for a web server, if you run this thrice, then it will create three different containers, and all these three will be an isolated environment. So if you change one, it is not going to affect the other container, right? So that is a very important thing to understand. So all containers are completely isolated. So next, let's look at the characteristics. It is mutable. So containers can be modified while running, such as you can log into the system and add files, but it is typically designed to be temporary. Okay, so the state in which you leave it, it is not persisted. So once you stop it, or if you stop the container or remove it, your data will be lost. Now there are ways to store it that we will see when we actually look at the example, right? But by default, it does not persist your data. Isolated, so containers run in isolation, so two containers do not interact with each other unless you share some data between them. Otherwise, both the containers will be running in isolation, and they are resource efficient because each container shares the resources of the host operating system. It is using the resources efficiently. Okay, so like for example, we created an image of a web server. When we run that image, that will be a container. Okay, so I hope you understood the difference between Docker image and Docker container. So now this video, as I explained before, it is going to be divided into three parts. So in this video, we are going to see how to run containers. Okay. And then in the next part of the video, we are going to see how to create our own Docker files, by which we can create our own image. And in the third part, that is the final part, where we are going to see how to define and run multiple containers using Docker Compose. Okay, so now to begin with, what we need is we need to install Docker Desktop. So if you are using Windows 10, then you can simply go to Docker website. So this is the link, and you can click on download and get the setup. And before you run the setup, you should know that you must be having Windows 10 or 11 64-bit with either Pro, Enterprise or Education Edition, because we will need Hyper-V, or Windows Home with WSL2. Okay, so if you have WSL, then that is better. And one very important thing, when you try to install Docker on your PC, a majority of the times the hardware virtualization feature on your BIOS is usually turned off. Okay, now if you even if you install it without enabling it, it will fail eventually. So it's better that before you start the installation, you go inside your BIOS, go to your CPU configuration, and check if hardware virtualization is enabled. Okay, so based on what type of BIOS you have, it may be called different. So if it is Linux, it may be called like VTX or Intel hardware virtualization or anything. So just look for something related to virtualization, so, and enable it. Once it is enabled, then you can download this Docker Desktop and run the setup, and it will do the rest for you. So once it is installed, you can go to this repo. So let me show you. Let me just click this link. Okay, so let me just go to my repo just to show you. So I have created few repos which will be helping you in learning Docker. So this is the first one, the first repo. So I will put the link to the repo in the description. So in this repo, I will be uploading all these commands which are related to Docker, which will help in running. Right now, let's first look at how Docker Desktop looks. So once you install and once you start, uh, you will get a window something like this. Okay, now a very important thing to note is at the bottom left hand side, this must be saying engine running. Okay, if it says engine stopped or some other error, then that means you cannot run containers. Okay, so you can go over here and try to do a restart, or if it is asking for some WSL restart or something, then just click on that and get it done. And if still it doesn't work, then the best option is just close this, uninstall Docker desktop and try reinstalling it, and it usually works. Okay, so once you have this running, then you can start running containers. Okay, so let me just go to the terminal. So you can either use the terminal provided by Docker, or you can use your command prompt from your Windows. It does not matter what you use. So I'm going to use this terminal. Okay, and here you can run the first command. Okay, so let me just start with the first command, that is docker version. So once I run this, this shows that Docker is installed on this system. Okay, and which version is installed? So it is 28.04. That is the version of Docker installed. Okay, now just understand, this is not Docker desktop version. This is the Docker daemon version, that is 28.04. Okay, so once this is done, now we can see that Docker is working. So now let's understand what are the different commands. So I will start with this file, that is Docker commands. Let's open that. So when you open this, you can see all the various different Docker commands that are available to you. Okay, now most of these commands are self-explanatory, right? So like for example, I want to see what are the containers that are running on my system. So I will just run docker ps. Okay, so let me show you. So docker ps. So when I run this, you can see I get a tabular form of all the containers running. Unfortunately, there are no containers, so I cannot see any entries. Okay, so then we can do different commands, like if you want to see how many images are there. So let me just go down. So how many images are there on my system? So I can do docker images. Okay, so let's see docker images. So you can see these are the various images that are present on my system. If you're using it for the first time, then obviously your list will be empty because you have not pulled any image till now. But because I've been using Docker for some time now, so there are lots of images. Okay, so like this you can try to run these commands and find out what each of them does. Okay, like for example, uh, this command docker rm and the container. So if there is a container which is running, okay, and you want to running or stopped container, then you can use this to remove that container. Okay, you can use this to stop a container. You can use this to stop a container. You can use this to start a container, right? And the most important command in docker is this docker run. Okay, now because docker run is so important, uh, what I have done is I have created a separate file regarding just docker run. Okay, so let's open that, and this is where we are going to concentrate more in this part of the video, docker run. Now running a docker container is a two-step process. Okay, so when we do docker run and some image name, so if that image is found in the system, then it just runs it. But if it is not there, then behind the scenes, there is another command that is run, that is docker pull. Okay, so now when you do docker run, you don't have to worry about pulling the image first from Docker Hub, but it does it automatically. Okay, so if that particular container, that image is not available on your system, then it directly gets it for you. Okay, so that's why I'm not showing you docker pull separately, but as soon as you do Docker run, it does pull the image if it is not already present. Okay, so let's try to run the first image. So let's say Docker run hello world. Okay, so the most basic image that you can run is hello world, right? So you can just, so hello world is a image name. Okay, it just prints hello world. Okay, so let's run this. You can see something just happened, and in the containers there is this entry that has been created, right? So it has created an entry, and also if you scroll, you can see that when I run this command, it said hello from Docker. Okay, and this message so shows that your installation appears to be working correctly. Okay, so this just some message that it prints out. But then the point is, it ran our first Docker container, right? So as soon as it ran, it did a few things. Okay, first of all, it gave a random name to the container. So for example, here, Keen Jackson, and it also gave a container ID. Let's run this one more time, and you will see now next time when we ran it, it gave a different name to the container and a different ID. So each time you run it, it creates a different ID and a different name. Okay, so now the problem is, so if you run this many times, then there will be unnecessary containers listed over here, right? So if you don't want this, then what you can do is you can configure this with flags. Okay, so you can configure this with as many flags as you want. Like for example, here between run and hello world, I can add rm. Okay, dash dash rm. Dash dash rm means auto remove. So since this container does not do anything, there is no point of keeping it in the list of containers, right? So I can just do like this and see what happens. When I run this, it did run the container, but at the same time the container appeared for a while, and immediately as the container stopped, it was removed, deleted from here. Okay, so let me show you once again. Let's delete it. Let's delete all the containers. So right now you can see there is nothing. If I run it with rm, you can see something came over here and it was deleted, right? So this is the first flag that we are going to learn, that is rm. So let's look at the rm flag. So auto remove. Okay, so auto remove, it removes the container automatically after it stops. Okay, now another very important thing that flag that we want to understand is the name flag. Okay, now if you see, let's go to Docker, remove the rm flag, and if I run this, you can see it created some random name. But let's say I don't want that. Okay, I want my own name. So what you can do is you can just add name, and let's say my container. Okay, so now when I run this, let's run this, and you can see now the container is created. There is a random ID, but the container has a name that I have selected, right? So that is the way you can give a name. So that is the second flag, that is name. Okay, now next let's understand the few of the other things in Docker run. Now to go through all these Docker run, so there are many, so you can just go through all of these one by one. I will show you few of them with examples. Okay, so let me open another repository. So for you to practice on Docker, I have created another repository with Docker examples. Okay, now this will help you learn Docker with examples. Okay, for example, let's see. run a simple Python program, right? So this is the a simple example. So let me just show you what is inside this. Okay, so let's open my editor. So this is, I have already opened that same thing, that is same repo over here. So you can see there are few folders in here from example 2 to example 14. So you can see all these are the examples. Okay, example 2 till 14. So once you complete all these examples, you will be pretty sure about Docker. Okay, so let's look at it one by one. So let's look at experiment number 2, example number 2. So example number 2 is inside this folder. You will see that there is a file, that is main.py. So if I open this, you can see there is nothing, just a simple program to calculate a simple interest. Okay, so if I run this right now, so if I run this, you can see it runs it something like this, and I can enter the amount, interest rate, and let's say period, and it calculates the simple interest. Okay, it's that simple. Now once I have this, so this I'm running it on my local machine because I have Python installed. But what if you don't have Python installed on your machine? So then, do you have Docker installed? So if you have Docker, then you can run this container, you can containerize this application. So let's begin how to do that. Okay, so let's use this terminal. Now, just to explain you that I have opened this terminal. This is the terminal of Visual Studio Code. Now, it does not matter where you run the Docker commands. Whether you run it on this terminal or inside this terminal, it does the same thing. Okay, but only thing you have to note is whenever you run the particular container, so whenever you want to run, let's say for example I want to run this Python program, then first you have to go inside that directory. So for example, right now I am in Docker examples directory, but my program is in the exp2 directory. So if I have to go inside that directory, so I can just do cd. Okay, and you can see I'm now inside this. So if I do ls, you can see the main.py is present in this folder, that is this code. Right now, instead of running it like this, so if I want to run it right now, I will just do python and main.py, and that will run the code, right? But I don't want to run it like this. I want to run it with the help of Docker. Right now, to run it with the help of Docker, we need to transfer this code to the Docker container. So let me first select a image for this. So I want to run this Python program inside a Python container, right? So first I have to find a container, or first I have to find an image which has Python built in, right? So let's go to, so I want to search for images, right? So if I want to search for images, I will go to this website, that is the Docker Hub, right? So Docker Hub is the website where you will get images that is published by Docker as well as other users, right? So instead of creating an image from scratch, you can first search for the image that you want on Docker Hub. If you do not get that image, then you can create your own image. Now, how to create your own image, that we will see in the next video. But for the time being, we are going to use pre-built images, right? So let's search for Python. Okay. So when I search for Python, you can see there are many package, many images with Python, but I will be selecting this one which has this badge in front of it, that is Docker official, right? So that means it is created by Docker itself, right? So you can see how what is the name of the package. Okay, the name of the package is Python, right? So if I go to, so in every package or every image, you will see the first page, that is the overview page, gives the details about the different tags, then what is this image, how to use it, and everything. So all the details related to this image will be available in this description. Okay, then if I go to tags, you will see, so what are tags? So tags are nothing but a way to select, let's say for example, you want to select an older version of Python, okay, or you want a specific version of Python. Like for example, look at this over here. So this is the version of Python 3.14. Okay. Now what if you want something old like 3.12? So this is how you select that version, right? So that is what the use of tags are. Okay. So look at the way you define the tags or you use the tags. So first you start with the image name is Python, then you put a colon and then you put the name of the tag. So this is the actual name of the tag. Okay. Now if you do not put a tag, that means if you do not put this colon and whatever is following that, then it is assumed that it is latest. Okay. So let me just go to the top, and so for example, if I do this docker pull python, then it means I am looking for docker pull python colon latest. Okay, that is this image. Okay, now when I pull this image, you can see what will be the size of the image. So for Windows AMD, it will be around 3.22 GB, because that is a big size, right? So it is going to use up a lot of your disk space, right? So we don't want that. So instead, what we can do, so in many of the packages, so let me go to overview again, and if I come down, you can see in many of the packages there will be a variation called Alpine. Okay, so every image that you see over here, it is made using some base image. Okay, so like for example, if I start the base image, if it is with Ubuntu, then Ubuntu itself will be a big image, right? Big size. Now if I start with Ubuntu, then whatever after installing Python inside Ubuntu, the image that results will be obviously bigger, right? So the size of the image will be bigger because the base image itself is bigger, right? So if I can use a Linux which is small in size, then my final output image of Python will be much smaller, right? So in many cases in Docker Hub, you will find that there will be an image which is bigger in size, but at the same time there will be other varieties like the Alpine variety, which will be very small. Okay, let me show you. Let's go to tags and let's filter using Alpine, and you can see there are Python with Alpine, and look at the size of the Alpine image. It is just 18 MB, right? So in the previous case, when we looked at the other variety, we saw it was around 3.2 GB and even 300 400 MB in case of Linux variant, right? And here you can see it is just 18 MB, right? So that is the beauty of using images which has a tag of alpine to it. Okay, so we were going to use we will try to use whichever image we select. We will try to find whether alpine versions are available. If they are, then we will be pulling that. Okay, so let me show you how to get that. So let's go to our VS Code terminal. Let me just increase the font size. Okay, so this is the terminal. Okay, so let's begin. So let's run the container without any flags. Okay, so for that the command is docker run. Now name of the image is Python, right? Now if I do like this, then it will download the bigger version, that is around 300 MB. But if I want Alpine version, then I have to add Alpine to it, right? Now when I do this, it will now pull Python Alpine Linux version, right? So if I run this, you can see it executed something, right? But it did not download anything. Reason is because I have already let me just go to images and let me just filter Python. You can see it is already present, okay, of size 44.83 MB. Let me delete this, okay, just to show you. Okay, so first let me go to containers and delete everything so that, okay, now I will go to images and delete this. Okay, so now I don't have the Python Alpine image. Let's go to VS Code and run that again. Now you can see unable to find image Python. Now it is pulling it, right? And it downloaded a newer version of Python Alpine. Okay, now when I did this, it first of all downloaded Python Alpine. Okay, so if I go to images, you can see Python Alpine is back. Now if I go to containers, it has also executed or run the Python container also. So first it downloaded the image and then it also executed it, right? But unfortunately this container did not do anything because we just executed it, but we did not say or we did not ask it to do anything, right? So it came up, ran the container and it exited. Okay, so now how do you know whether the container is running or not? So you can see this dot over here. So this dot, if it is green, it means it is running, else it is exited. Okay, so right now you can see it is exited. Okay, so let's delete this again. Okay, now let's understand, or let me explain you how to run this main.py inside this Docker container. Okay, now to run it, the first thing that you want to do is transfer this program. Now, right now, this program main.py is inside my host machine. Okay, it is not inside the container. So the first step would be to transfer it inside the container, right? So let's run this command. Now we are going to customize this. Okay, so between the docker run and the image name, we are going to add few things. Okay, so the first thing is we want to copy everything from the current directory to some directory inside the container, right? So for that we are going to use something called as volumes. Okay, so that is the next tag that we are going to learn, that is volumes. Okay, if I come down in our, so you can see I can create mapping. So when I say -v, when I run a container with -v, it expects after that two paths separated by a colon. It expects two paths. One is which folder do you want to map from your host and to where do you want to map in the container. So this is the host path. So where do you want, which folder do you want to be mapped, and in the second part, that is after the colon, is the path of the inside the container, right? So let's do that. So it's the current folder. So if you want to reference the current folder, you can just put a dot, right? Then put a colon. So dot means the current folder, right? Then put a colon, and then where do you want it to be copied in the container? So let's say I just say some random folder called app. Okay, now it's a Linux container, so everything in Linux will start with a slash root folder, right? So that's why the name of the folder is slash app. Okay, so now when you run this, it will copy everything from the current folder. Now right now in this folder there is only one file, main.py, so that will be copied into this folder, that is app. Okay, so let's run this. Okay, so here you can see, because I'm using the bash, okay, so it is giving me an error that you cannot use dot. Okay, so if you get this error, then you can simply do dollar pwd. Okay, so when you do this, it simply means you are telling that the present working directory of the host. Okay, so that is this folder where the main.py is there. Okay, this is only when you get an error when you use dot. Okay, now if I would have used, like for example, a command prompt. Okay, so let's use a command prompt, right, and get inside exp 2, I guess, right? Yeah, and now here I run the same command. Let's say what was the command? Yeah, this one, right? So let's copy this and let's go to cmd and paste it. Now if I run this, you can see here it works, right? Here the dot is considered as the current working directory, right? Because um, in bash the dot is a reserved string, so in bash script it does not work. So if your default terminal in VS Code is CMD, right, then dot will work. But if your default terminal is bash, then you can use the second syntax, that is pwd, dollar in bracket pwd. Okay, so instead of running it in the Python bash terminal, I'm going to run it uh, in the command prompt. Okay, so I will just select this, and from here I will select command prompt. Okay, command prompt or PowerShell, whatever is there, that will do. So let me just close the other terminals and let's run it in the command prompt. Now here I'm going to run the command docker run. So here I'm going to put the volume, that is dot colon slash app, and the name of the image Python Alpine, and let's run ls. Okay, so let me explain this command again. So I'm running a Docker container. The name of the image is Python Alpine. Okay, and I'm mounting a volume where the current directory is mounted to slash app directory. Okay, and then I'm running a command ls. Okay, so if I run this, you can see I get all the folders in the current directory, and these are just basic Linux folders, right? But look at this folder, the app folder. So you can see some folder called app is made, right? Let's see by getting inside this directory and find out what is inside that directory. Now, if you want to change the working directory of the container, then you can use the flag W. Okay, and you can specify the directory which you want to start with. Okay, so let me show you that. So let us go down. You can see set the work directory minus W. So this is the same example. So I'm setting, first I'm copying everything to the app folder, then I'm setting the work directory as app. Then I'm doing ls. Now if actually this program has been copied inside the container, then I should see only main.py. You can see. Okay, so that means our docker command is working. Now this is not what I want, right? I have copied the file to the container, but it's not running it, right? It is just displaying that the file is present inside the container. Now to run it, you will run it something like this. Okay, so you give the commands. So usually when you want to run it through terminal, you would say python space main.py, right? So same thing, you have to do it over here also. So python, so this is the program which will be used to run it, and then main.py. Okay, so let's run it. You can see it started the execution, but it resulted in an error. Okay, the error is an unexpected error occurred, end of file when reading a line. So this is the place where we introduce our next flag. Okay, so now the problem with this command is it is working. It even executed our program. You can see the program started execution, but at this point it was expecting an input from the user. But this command does not allow the user to interact with the container. Okay, now if you want the user to interact with the container, then you will have to add another flag, that is IT. Okay, so let me show you. Let's go to the top and let's look at IT, interactive mode, right? So if you add this flag, okay, it does not require any parameters. So just add IT. Now the user can interact with the container. Okay, so let me show you. So once I do this and press enter, you can see now it is waiting for our input. It is not giving you an error, rather it's waiting for my input. So let's put some input, 10,000, 12% interest for 15 years, and I get the result, right? So this is how simple it was to execute or run a Python program inside a Docker container. Okay, so now how, just let's do a quick recap. So let me just clear everything. Now let's start by running the Docker container. So I will start fresh. So Docker run, the name of the image Python, and I want a smaller image, so I will select Alpine. Okay, so that's it. Now I want to um, add some flags so that it works properly, right? The first flag that I'm going to add is I want to copy all the files from this folder to a folder inside the container. So for that I will need to use volumes. So this folder means dot, that is the current folder, and inside the container I want to copy it to any random folder that you want. I am selecting as app. Then using W, I'm going to select the current working directory. Because I've copied it inside app, so I'm changing my working directory as app. Okay, then because this program requires the user to input something, so I am going to add the IT flag. Okay, now once this is done, now this container does not do anything. Okay, it just runs it and leaves it. So if you want it to do something, you will have to specify. So I will say Python main.py. Okay, and if you run it, you can see I get the result. Okay, so this is the example number 2. So we have seen with the help of different examples that what all things you can do with docker run command. Okay, there are many more. We will take a few more examples and we will understand how the things work. So let's go to the third experiment or third example. Let's close this. So the third example is related to simple interest only. So let's look at the repo. So the third example is a run a simple program but using CLI parameters. Okay. So the previous one when we tried the users, it was waiting for users input. So the flag IT was very important because the user had to give some input. But here we are going to run it with the help of parameters. Okay, so CLI parameters, like for example, you can see I'm going to give, so let me just show you what I mean by that. So let's clear. Okay, and let's do a cd dot dot, go back one folder and get inside experiment number 3. So cd example number 3, and let's do ls. So there is main.py. Okay, so let me show you the code first. So code is something like this. So here you can just see what I'm trying to do is I'm trying to calculate the simple interest, but instead of taking an input from the user, I'm using arguments. Okay, so the first argument is the principal, second argument is the rate, and the third argument is the year. Right, so if I want to run this right now, let me run this python main.py. Okay, so in the previous one it was waiting for input to be given by the user. Here it will not wait for input. The input has to be given through the command line itself, right? So I will say 10,000 or 10,000, then 12% interest, and for 15 years, right? So from the CLI itself I'm giving the input. So if I run this, you can see I get the result directly. So it is not waiting for any input as such, right? So this I have to run using our Docker container, right? So again, it will be very simple. So let me just close this and let's try it out. Okay, so let's do the same thing. Docker run Python, right? Alpine. Then I don't need interactive, but I do need to copy this file to the app folder. So I will use volume dot colon and slash app, then change the work directory to slash app, right? So these two things are done and I don't need interactive. So I will just try to run the program. So to run the program, I will just say python main.py, and here itself I will give the parameters. So let's say 12,000, 12% and 15 years. Okay, so let's run this. You can see it executed perfectly, right? So what it did, it copied the program to the app folder, changed the work directory to app folder, and then it ran this command on this container and it executed our program, right? So that's how easy it is to run anything inside your container. Okay, so let's take another example. So similarly, you can try this as a homework. So if you want to run a C program, you can use so I have given a simple C program in example 4. You can try to run it in Docker container with the help of image name called GCC. So if I go to Python GCC, so you can see there is an official image of GCC, that is GNU C compiler. So you can use this to run and compile Docker, C programs in Docker, right? So the solution is given over here. So you can try it out first, and if you get stuck, you can try this command. Okay, now very important, let's try the next one. That is, if I want to host a static website using Docker, right? So let's see how to do that. Now if you want to host a static website, you will need uh, a web server, right? Now the popular web server is Nginx, right? So we will search for Nginx. You can see there is Nginx, and there is also HTTPD, that is your Apache web server, right? So if you like Apache, you can use this. If you like Nginx, you can use the other one. Okay, I'm going to use Nginx. So let's look at that. So let's go to the Nginx, that is 5, experiment number 5, example number 5, sorry. Okay, so let's first go inside that folder, cd dot dot cd example 5. Okay, okay, so let's close this and let's open. So it has only two files. One is the index.html and a main.css. If I open index.html and if I try to show using a live server, you can see this is what it looks like, hosted in Docker, right? But right now it is not hosted in Docker, so I want to run it inside Docker, right? So to run it inside Docker, let's see how we can do that. Okay, so first of all, I'm going to use Nginx. Let's search for Nginx, go inside Nginx, and important thing is, if you go and read, first thing to note is there is Alpine, so you can see Alpine version is there, so we'll be using that. Next, let's go down. Now very important, there are some hints given as to how to run the Docker container. The most important part is this volume part. Okay, because in the last example we copied into /app inside the container, right? But when you run using Nginx, where you will copy, that also matters. Okay, so that's why you need to understand where this particular image is configured to load the default pages. So you can see currently it is configured in this folder. So if you copy your files inside this folder, then it will be much easier, right? You could change the folder, but then you will need to change the config also. So if you do not want to change the config, then I would suggest just copy your HTML and CSS inside this folder so that you don't have to do much changes. Okay, so let's try. So let's do docker run, then the name of the image is nginx. Okay, but I want a smaller image, so I will say Alpine. Okay, but this much is not enough, so I will put certain flags. The first flag is volume, so I will mount the current directory to the directory that is this one. Let's copy that and paste it over here. Okay, then so once I run this, so now if I run this like this right now, if you see few things you will notice. First, when I run this, you can see this particular terminal gets stuck. Okay, because it is waiting The Docker container is not a short-lived container. Okay, so whenever we run a Docker container, there are two types of containers. One is short-lived and one is long-lived. Short-lived is like in example 2 and 3, when we executed a program or when we executed something, it ran the program and then it exited, right? But this type of containers, that for example nginx, then http daemon, so these containers are long lived containers, so they don't stop, they are continuously running, right? So these containers, they do one thing, that they uh, take away the access of your terminal from you, right? But we don't want that. We want to run multiple containers, right? So this is not the right way. So let's stop this Docker container. Now to stop this, you just do Control C, and that will stop the container. Now I will use up arrow to get the last command that I've executed, but instead of running it directly like this, I will add a flag called -d. Now what is this -d flag? Let's go to our, that is this one, detached mode. Now detached mode means it runs the container in the background. So when you run a container in the background, you get back your terminal, so you can run other commands, right? So let me show you the difference. Okay, so just look at this, what happens if I run this. You can see it does not show any output, but it gives a big string of characters. This just shows that your container is running, but it is in the background. Okay, so let us go to Docker desktop, go to containers. You can see there are so many containers that we have executed, but at the end you will see the latest container, Hungry Benz, which is actually running. Others are just they have exited, but this one is actually running, right? So only this one is actually working. Okay, so let me go inside this and show you what all things you can see. Okay, so these are the different tabs inside a running container. So these tabs can only be seen when the containers are running, right? So the first one is logs, so that is helpful to identify if the container exited due to some error, so all those errors will be visible over here. Then these are the mount points, so you can see this folder, example 5, is mounted to this folder in the destination, that is inside the container. Then exec is where you can check out the different files and folders. Oh, sorry, this is the place where you can run, this is the terminal of the container. Okay, so for example, this terminal is the terminal of your computer, host computer, that is of your Windows, but this terminal is the terminal of your container, running container. Okay, that is your nginx alpine container, right? So if you do an ls, you can see these are different folders here, right? So you can go inside user share nginx folder and see your files. Okay, now just to be sure, you can come to the last tab, that is files, and you can see the same thing that we saw in the exec ls command, and we can check out the different folders that are present inside the container. So if I open this user folder, inside this share folder, and at the end here nginx folder, and inside this html folder, you can see our two files, index.html and main.css. those are copied here, right? So that is just to confirm whether our data is there. Right now our server is working, right? So you can see our nginx instance is working, but now the problem is, so we have understood what is the d flag used for, to running in the detached mode, but now the problem is how will you stop this. Okay, so so this is running. Now how to stop this? It's very simple. You can select that particular container from here and click on delete. That will delete the container, right? But now the problem is, so let's run it again once more, right? So another container is running now. So you can see another container. But the problem is, okay, so our Nginx is running, but how to see the output? Now the output cannot be seen directly. The problem is the app that you are trying to visit is in this container, right? But this container is a Linux environment. That too, only terminal is accessible. That means there is no browser. Now, since there is no browser, I cannot see the output of a website, right? So, what is the option, right? So, one option is to forward specific ports from the container to the host machine, right? So, what do you mean by forwarding ports? So, now this container is running at port 80. So this Nginx by default runs at port 80, right? Inside the container, right? So if we can somehow transfer that port to the host machine on a different port, then we can use localhost to open and check out our website. Okay, let me show you how it's done. So let me delete this. So for that, we will check out the last flag that we are going to see, that is the expose and bind ports, right? So using the P flag. Okay, so let's do it one more time. So let's do a clear and then run this. But this time I'm going to add a flag -p, and now here you have to specify two ports. One is the host port colon the the containers port. Okay, so host port can be anything of your choice, but preferably greater than 1024. Okay, so let me select 8000 port. Okay, so on the host, this app can be seen at port 8000, and the destination, that is inside the container, the port is fixed, that is port 80, right? So the first part, this is your choice. The second part is where the Nginx is running, that is port 80. So now if I run it and go to Docker desktop, you can see now the container is running, but here there is a new the column which has a new entry, that is ports. Okay, so this can be used to check out your website. So let's click on it and you can see now the website address is localhost colon 8000. So you are opening this port, but you are actually going inside port 80, right? So that is how you forward the port from your container to your host. Okay, so this is how it works. So whenever your container requires to forward some port, this is how you do it using the -p flag. Okay, so let's delete this. So we have seen a lot of examples, right? Now as a uh, uh, if you want to try it out yourself, you can try this one. Example number 6 is how to run a express app using Docker, right? Now this is a sample app. If you have your own app, you can use that, but I have given this as the example. So and the solution is also given, so you can just try it yourself and try how to run it. Okay, now if it's a Express.js app, that means it will require Node.js image, right? So you can go to Docker Hub and find whether there is a Node.js image. So you will find this is the name of the image, Node, and there is an Alpine version also, right? So you will do that
then you will forward certain ports. So this app is built on port 3000. So on based on which port you have built your app, so that will be coming over here. This is the port on which it will be visible on the host. So this is decided by you, this is decided by the app that you are deploying, right? Then you are mounting the volume, the current directory to the slash app directory, changing the work directory to app directory. And now the best part, that is, you want to run some commands, right? So what commands do you want to run? So these are the commands. I cannot run a node.js app directly. First I have to do npm install. So I did npm install first, so that all the required libraries like express.js can be installed. Then I'm going to run node.js. Okay, so these are some of the examples of how you can run Docker in for running different containers. Okay, so the we have seen many of the flags. The other flags you can try it out, like for example setting up environment variables, you can do -e, right? If you want to set the CPU and memory usage limit, you can do this. Then you can set the restart policy, you can set up the network which it uses. So like that there are many flags. You can change the host name, right? But these are less used as compared to the flags that I have discussed. Okay, so whatever major times it will be helpful, I have already covered. Other things you can try it out on your own. Okay, so this is the end of the first part of Docker. So we, in this video, we have seen how to use Docker run to run your containers with your desired output. Okay, now in the next video we are going to see how to create your own images using Docker files. Okay, so in this video we have used ready-made images from Docker Hub, but in the next one we are going to create our own images. Okay, I hope you enjoyed it. Thank you everyone.